Hello, welcome. This is Terrell Russell. I work for the iRODS consortium, and I'm going to talk today about what we've been doing the last year or so with regards to policy composition. Title here is Policy Composition, Configuration, Not Code. So I work at the iRODS consortium, which is a member-driven organization inside of the Renaissance Computing Institute, or RINC. And RINC is a technology institute inside the University of North Carolina in Chapel Hill. So I'm a state employee and work for the university. Our membership at this time, I think, is 26 organizations, including RINC itself. Our membership is largely driven by people doing research, so that's people doing science, as universities, consortia of other schools, as well as commercial for-profit entities that are doing things with science as well, lots of data. Other group inside of our membership are storage vendors who are trying to be maximally compatible with all those people doing science so they can sell their hardware. And the third group is really technology integrators, so people that have a footprint somewhere that can actually be on the ground and help people install, support their systems. We usually train them, and then perhaps through some kind of support contract or tier 3 support, we can help them help our users. So today's talk is going to be about what we've done the last year or so with regards to policy composition. So we have watched a variety of organizations across different domains around the world begin to do data management in an automated way. And so this is great. It requires a flexible system for a diverse group to be able to do that. And many of them have picked iRODS, and we're very happy to help people get their stuff done in a good way. What we have noticed is that means that people are reinventing the wheel a lot of times, and they have built these monolithic specific policy sets around what they need to do, which is great that they have the flexibility to do that. But we have noticed some redundancy and duplication of effort, both within particular domains of science, but also even across. I mean, everybody wants to do the same things, but they may be using different words. And so what we've done here with a new approach is to actually provide some building blocks and compose these policies rather than having people write them themselves. And so as an example today, we're going to talk about storage tiering, which is one of the things that we've provided for a couple of years, but this new way of doing it we think is better and more flexible moving forward. So to back up a little bit, talk about data management itself. Data management really is about writing down and having good plans, as well as how to execute those to take care of your stuff, right? To enhance the value of your data, both in flight and at rest. We think that organizations need a future-proof way of doing this in order to do it well. And largely that means that they need to insulate themselves around changing infrastructure and perhaps even changing management. The people in charge may make different decisions, and the rules might change. So in order to understand that, definition of a policy itself is really a plan of what to do when something happens. And generally that's going to be agreed to by people. So the people who are running the organization, they are in charge, they are smart, and they sit around a table and decide what policies we should have in place when things happen. And how does iRODS interact with this? Well, from our perspective, a policy becomes code. So if you've got a policy that needs to be enforced, we can help you write some code to do that. And that is a reflection of that data management policy, those decisions that need to be made in code that a computer can execute. So it really is about what to do when certain things happen. And what we've seen, this bit of redundancy around the world, is people are trying to solve the same problems. And they would like to have policies around when and where their data moves, when they want to verify it, what systems it goes to, the checksum protocols and how they're in place, things around the metadata. Do they have good templating? Is the metadata good? Can they prove that? As well as making sure that the stuff on disk is what it was when they put it there before. So These things are all important, and everybody's trying to solve them, and so we're here to help. Our data management model really kind of stacks from the bottom up, and we provide some core technologies, some core competencies, and on top of that, we think we can help people write their policy. From our perspective, we use policies to build capabilities, and then the capabilities are what we've noticed that people have done many times around the world, and we call those the patterns. So these are the words I'll be using today. So when we come to help people, the questions really are, well, how do we get them off the ground? Once we help them write a policy, what is it that's reusable about that? Can we make the approach to this even simpler, both in terms of development as well as deployment? Can we provide a cookbook of the things that we've seen around the world? So how can we get from policy to capabilities without making this a very high mountain to climb for people? And this approach now is that we're going to be considering policy actually as building blocks to build towards these things that people want to do. We're going to use proven software engineering principles to do this. And this is really about favoring composition over these monolithic implementations that we've been building ourselves, but also seeing other people build. And one of the ways that that works is that through the different rules and policy enforcement points inside of the iRODS system, they can now play well with each other a little bit better. They're not going to step on each other's toes as much. And that means that these policy enforcement points can actually be overloaded and fall through one to the other and allow each other to handle one case well. That means that we can separate the concerns, and actually when you build them back up together, you can actually achieve pretty complex use cases. So a little history here. The original approach of what we've done in the past was to provide a policy enforcement point, in this case, this AC post proc for put, which is something that processes data after it was put into the system. And what we noticed and what we've done ourselves over many years is that this gets overloaded with all the different things that someone might want to do when a file lands in the system. They may want to extract and apply some metadata based on where it is. They may want to replicate it to somewhere else based on where it is. They may want to do some indexing based on the type of data it is or where in the collection hierarchy it is. They may want to compute some checksums if it's of a certain size or of a certain value. And so all kinds of these things are what people want to do, and they were all handled in one place. And this was a little bit brittle and hard to maintain because you had multiple people over time needing to change this, but in order to change it, you had to understand all of the other code that you may be interacting with. And so while it was functional, it was a little scary for people. So the second approach is to kind of separate those concerns a little bit. And we started to pull out the metadata extraction piece from the indexing piece, from the replication piece. And so we would put these in different rule bases or different plugins, and then started to allow these things to fall through one to the other, depending on what time of day it is or how big the file was and things like that. So an example of this would be to separate that metadata extraction from the checksum, from the access time code, and put those in different rule bases with the same policy enforcement point at the top. And that allowed them to play well, but still fall through. And the fall through mechanism was handled by the framework itself. So we've still got a set of rules, everything still behaves. We've expanded our mind a little bit because we've separated the concerns, but now they need to be in a particular order. And you can see that metadata would take precedent over checksum, over access time. So having learned all of that, we still saw these things as a little bit monolithic. So we were going to consider storage tiering here as a collection of policies and start to work towards separating these out and then building them back up again. So storage tiering itself really is a set of policies around stamping things with access times of the last use, figuring out which things it's time to move, how to move them, how to verify that they've moved, and then of course how to trim the things that have become old or stale or don't need to be there anymore. So our first implementation of this a few months ago, about a year ago maybe, we did this with monolithic plugins with a bit of duplicate code in a few places, but this was delegated to the system by naming convention. So we went to a string-based solution, and it allows very flexible, but again, we had a little bit more work to do. But it did prove the experiment, and it showed that this could be done and then stitched back together again. But we still needed to separate out what they were doing because a lot of code that was in one was also in the others. So we wanted to separate the when, the what, the why, and the how. And so I'm going to go through each of these four and talk a little bit about how they work and show you some examples of what we've done. And the idea here is that instead of writing complex pieces of code, we're going to write particular policies, the what, and we're going to make them do one thing very well and then separate how they get called and when they get called. And so that means that these policies now can be nice and generic, and stitching them together becomes the interesting part of the exercise. So first is the when, and I showed you a couple of the policy enforcement points earlier, but there are many, many in the system. Every operation in iRODS in the system has a pre, post, except, and a finally hook that can be invoked by writing policy. And this is a bit overwhelming because people don't know where to go and which ones to use. It's extremely flexible and powerful, and those are still available to you if you know what you're doing and you want to write at that level. But what we're trying to do here is provide an event handler and boil those down into the 6 or 7 concepts that someone might actually care about when a put comes into the system, so to say, or whether somebody puts metadata on an item. And so at this point, you can think about when. So if a file was created or a file was renamed, that's what you need to consider, and then you can fire the policy that you want to fire. And so the way this works is that we've got a particular class in the code for each of the nouns in the system. So we've got an event handler around data object, an event handler around a collection, an event handler around metadata. And these invoke the policy based on how they are configured. So a particular example would be the data object modified event handler. And so this allows you to provide configuration in code for these 6 particular operations, things that can happen to a data object. The policy invocation is then configured as JSON. And what this does for us is it unifies the POSIX and the object behavior that we've had for years, but that people don't necessarily expect or don't code to because they haven't worked with a system that allows this flexibility and abstraction. So this combines them again for people that want to deal with streaming interfaces as well as object semantics, and puts a single place to configure and define that policy. So here's an example of what a synchronous invocation looks like. And you'll notice here, this is when a data object's modified, this will be after the post hook for both a create, write, and a registration event. And it's going to stamp the access time on that object. Before replication, it will run some other policy example. And so this shows how we've got more than one policy enforcement point kind of wired into and operating on a particular event. And so the order still matters if more than one policy does need to be invoked when a thing happens. So the what is really about the policy itself. So some of the basic policies that are leveraged across many things, again, are this access time, how to run a query and then operate on the results, moving the data, replicating the data, things like that. And so as we learn more, we're going to add more to this. And these policies can be defined in multiple different languages. We have rule engine language for the iRODS rule language, Python rule language, and of course C++ rule engine plugins, which are don't have an interpreter, right? So they can run at machine speed. So you can prototype in one language and then write a rule engine plugin in another. And the big point here is that across all 3 of these, we've standardized the JSON as the interface. So parameters and configuration are the only thing that we need to know, and the rest of this is by contract. Policies can get invoked either through direct invocation with an object, through the results set of a query processor, or through an event handler itself. So that's the one that we showed you earlier. Each invocation convention defines that interface by contract, and they all are basically equivalent. So for direct invocation, you've got 2 parameters here, object path and then the payload. The same thing can be done statically down here at the bottom in the config. You see object path and then that temp zone home rods Same idea. The query processor can again run on a result set from a query. So in this case, it's going to enqueue a rule to run later, and this is going to run, so select username, collection name, data name, rest name inside of a particular collection name. And then that result set will get operated on concurrently with 4 threads, up to 10 at a time, and it would run on a row that comes out looking like the thing at the bottom there. And then the last way that you can invoke something is with an event handler. And again, all of these things have full knowledge of the context of who's running them and why they're running them and all that kind of stuff. So all of this material is available to the logic to use as conditionals. And the last little part here is that any other specific types of configuration can be added and just passed through because the envelope is the same for all of these. And then so the why is really about those conditionals. So every policy can set a conditional around when it should run, because maybe it doesn't want to run it for all files that get put in the system. So again, we've got a regular expression available to you, and that's what we're using to decide when things happen. So if you want to match on a particular logical path, only something that looks like this for a post put will the data replication occur. And that means that you can control that only certain things in your tree would get replicated over to the other resource. Here's an example of matching particular metadata and then invoking an Elasticsearch indexing event. So after data is put or written, then it's going to delegate to the collection metadata event, which would have a conditional around whether or not this information had a particular type of metadata on it. And if it was tagged to be indexed, then it would fire off a full text indexing job over to Elasticsearch. The last of the 4 here is the how. And again, this can be, we saw an example slightly earlier about the enqueue and execute. So this is really about how to do things on the delayed queue. And we've got one to be able to run it right now. Here's a simple delayed rule for asynchronous execution. So again, this is what we saw earlier. We've got the execution inside of that enqueue. It'll go under the delay queue, and then iRODS will pick it up just like any other job. And that means that these are the 4 pieces that allow us to define and separate when these policies are run and in what scenarios. I've got another minute or so. Go through a couple of examples. Here's a synchronous access time event. So after all of these events, a post of all of these, we just stamp it with a timestamp. Here's a synchronous replication. If any of these things happen right after that, we will replicate to a particular destination if it was on a particular source. And then here's one where it's always going to go to a particular destination. Here's the same code, but inside of an enqueue, right? So this will be an asynchronous replication policy. Here's a synchronous retention policy. So after a replication occurs, we will trim a single replica on a particular source. So in this case, if something was moved over, we now can trim the source material for that replication. And here is a query-driven asynchronous retention. So again, the results of this will be potentially trimmed. Here's a verification on disk based on either the catalog or file system or even a checksum. This is the same thing inside of a delay. And then here's the example that we talked about at the beginning for storage tiering. So we've seen some of these already. Again, storage tiering really is about asynchronous discovery, asynchronous replication, synchronous retention, and then marking things well in the catalog. So this is what the asynchronous discovery and replication looks like. This is what the synchronous storage tiering looks like. We've got all of these things happen after a replication event. You've got to tag things, you can do more verification, and then you can do the retention like we saw a second ago. And then this is a way to do metadata-driven restage. So maybe if you put a particular flavor of metadata on an object, it could get restaged back to a higher level tier. So again, about out of time, but this is our big picture data model, and these are the things that people want to do, this publishing, auditing, indexing. We can now do them with some building blocks and some configuration. This is a really big deal for us, and we eventually want to roll out a policy GUI so that we can actually edit these things in a safe way on the computer, in an admin GUI in some way. And the takeaway here is that data management really should be about the data, and it should be driven by the metadata. And if you want to do this in a good way and you want to be future-proof, it really does require open formats and open source. Thank you so much.